Hello, my name is Jeffrey1, and this is Module 3 project, Reaction Timer. Goals of this project is to design a game to test the reaction time of the user. Pressing and releasing start button triggers the timer and the LED to count up and light up respectively after a random amount of time. I'll measure the time it takes for the user to press the start button again when the LED lights up in order to measure the individual's reaction time. Procedure Step 1. First, I created 100 Hz clock signal by dividing out the 50 MHz original signal from the E0 board, which comes from pin G21. I did this by creating Gen 100 module, which takes in the 50 MHz signal and outputs 100 Hz signal. Every time the module counts 250,000 pulses, it switches 100 Hz clock signal from on to off or off to on. Therefore, 500,000 pulses create one up and down edge pulse for 100 Hz signal. Here is the coding for Gen 100 module. Step 2. I created the counter module, which counts the each positive edge of the 100 Hz clock and increments BCD digit from 100th seconds to 1/10th seconds to 1 second in ripple-like order in if loop. So how it works is when 1/100th second goes to 10, it goes to next digit, which is 1/10th second. So when 1/10th second reaches 10, it carries on to 1 second in ripple-like order. I also included the LED output argument, which turns on the LED, which is in pin 11, when the counter module starts the counting procedure. And here's the coding for counter module. Procedure Step 3. I created a simple 7-segment display module that takes in the BCD input from the computer module and output pin information for the 7-segment display. The method were explained in both first project and second project, so I will not be explaining the details of the method, but I'll provide the code later on. Also, the DEC value, the decimal variable in the module, turns on the decimal point for the 1/10th and 100th digit of the reaction time. So the D0 board represent 1 second, point, 1/10th, and 100th digit of the reaction time. And here is the coding for 7-segment display module. Procedure Step 4. I created LFSR module, which takes in start button, 100 Hz clock, and reset button to output random interval. I got huge help from website, which I would like to reference here. The constructor of the module was mostly referenced from this webpage. In my case, the 8-bit shift register is constructed in order to create the delay in the counting sequence and LED light up when the start button is pushed. Since we used 8-bit shift register, the maximum length of the delay is 1.27 seconds, which we can solve here. 2 to the 7th minus 1 is 120 ticks, and 120 ticks in 100 Hz time scale translates to 1.27 seconds. Since the initial state can be anything other than all zeros, I define the reset value as the 8-bit binary 11111111. And here is the coding for LFSR module. In conclusion, the project was overall successful as the demonstration met all the criteria required. and the demonstration will be followed from it will be followed from this slide. Thank you. Hi, this is the demo portion of the project. This is my program, reaction timer, and I'll be installing the program into the ECEN board right here. So same as before, go to Tools, go to Programmer, and we'll install the program into the board. It says successful, and we'll go to the board. Now I set this button as start button and this button as reset button. So when I press start button, LED light should come up and the time should start counting after random interval. So let's start. Right now I stopped the time from ticking after LED lights up in 0.96 seconds, as you can see, and I'll reset the time and try again, which turns on the LED, turns off the LED and sets time back to 000. Now let's press start again. This time I got better result by putting 0.23 seconds in my reaction score. Let's actually start it again. Let's see. Start it again? Okay. And I can start that again, start again, start again, start again, start again, start again, and reset anytime I want. Now let's see if the first let's see if the LED light up interval is truly random. Let's see. 1, 2, around 2 seconds. Let's reset. 1, 2, 3, about 3 seconds. 1, 2, 3, about 3 seconds. 1, 2, 3, 4, 5. Oh, I didn't start yet. Oh, yep, that was almost instant. Let's reset. Start again. About 1 second. Therefore, I can prove that the program's first LED light up is almost is pseudo-random generated by my pseudo-random generating module, which is the LFSR program right here. It creates the random interval for the starting time of the reaction test. Therefore, I conclude the demo by saying that my D0 board displays all the criteria required by a project, and I conclude that the project was overall successful. Thank you.